So this is 1 over lambda e raised to minus x, 1 over lambda e raised to minus y. So 1 over lambda squared e raised to minus x plus y over lambda. So I'm going to substitute that here. So this is 1 over lambda squared e raised to minus x is z minus y plus y over lambda dy, right? So that's 1 over lambda squared. Then notice 0 to z e raised to minus z dy. So this also goes outside. So we get the result z over lambda squared e raised to minus z over lambda. Z positive. So this is, if you go back and check your notes, this is a gamma density function. So it goes like this. So you get a theorem. If you add two independent exponentials, you get gamma. This is how you prove it. I'm sorry, if you add two independent identical exponentials, you can try to do this with different lambdas. Then you are not going to get this result. You can see it quickly. So you have to have the same parameter lambda. So if x and y are independent and have the same parameter and exponential, then the sum random variable is gamma with the parameter lambda and 2. And now try to do it at home with the lambda 1 here, lambda 2 here. You can do it, but it's not going to be this one. Let me do one more variation of this problem. Any questions? What?
The third part of this is
Yeah, where is this? So, where is the, remember we are taking the derivative of this with respect to z. Where is z here? Right?
yes.
See, here purposely I wrote z here, right? So if there is no z here, then this term will be 0, right? But there are some problems where there may be c, so that's why I rewrote. So let's do another problem. So this is also a classic problem. X and y are independent uniform random variables. What is the density function of their sum? So we use exactly the same idea. So you, of course, if they are independent, you can say, so remember, fxx is like this. Fyy is like this. So this is the advantage. You can use information from other courses here. If you know how to convolve two functions, you already know the answer. Remember, I'm telling you the two random variables are independent. And so the density function of their sum is? Of what? Convolution of two rectangles. So anyone, if you convolve two rectangles, what do you get? Well, if you know it. If you don't know, then you go through this, right? So let me quickly do this. So the answer is, triangle goes from where to where? Anyone? So that's just a convolution. If you convolve this with this, what do you get? 0. This is it? And? That's it. That's the... All right, so let me quickly show you this. So again, I'm going to give you the homework is already uploaded, I think. There are a lot of problems. I'll give you some more problems to practice. If you cannot do any one of them, we can try on 14th when we meet. So but I will also release tonight few previous exams. So here is a problem. Try to do this at home. So x and y, you can find out k. In this region, and the joint density function is, let's say, of this form. Find out the density function of z. So again, draw integrate where so this is the line x plus y equal to c. So where are you going to integrate? Which means? We are only going to integrate here, right? So you can take a strip like this, etc. So you need to try it at home, right? I'm not, let me see whether that, first of all, let me make sure that function I gave you is a density function. So this is the region where, what is the property of this region? Anyone? How do you represent that region? What is the relation between x and y there? X equal to y?
No, x is larger.
X is greater than y, right? So that's the density function. X goes from y to infinity, right? And y goes from 0 to, so if you draw that, so what is it? E raised to minus y dy. Yeah, so that's good, right? X goes from I mean y the other way, right? Y goes from x to infinity. Yes? Y here goes from x to infinity. So y goes from x to infinity. So if you integrate this, so this should be e raised to minus y, I guess. All right, so then that's okay. So this you integrate this e raised to minus y over minus 1. But that will come out to be e raised to minus x. And that you integrate from 0 to infinity will be 1. So that's a proper density function. With the k is 1. So try to do this at home and see what you get. Anyway, let me quickly finish up this problem. So if the density function is in this region, right? So you can also always use this argument. This is y, this is x. FCC, remember, FCC is probability of z less than or equal to x plus y here, less than or equal to c. So that's going to be a line like this way, right? But notice that I could draw a line like this, or I could have drawn a line like this, which means there are two cases. A line, this is also x plus y equal to z. This is also x plus y equal to z. So so the two cases are, I'll redraw it here. One case is here, we'll be integrating here. Another case seems to be here, we'll be integrating here. What's the difference? The two regions are different, so we have two cases. And how do you figure it out? You have to, each problem, that's why you solve problems, you see what's the, so how do you characterize between these two cases? Anyone? This is the line x plus y equal to z. What's the difference? Anyone? Distinguish with these two cases.
It's more than a z.
So one case is z goes between 0 and a, and the other case z goes from a to 2a. So let's so integrating here is easy because what is the density function? Look at here. Density function is constant. They are independent. So the joint density function value is how much? Density function of x is 1 over a, density function of y is 1 over a. So the joint density function is 1 over a squared, it's a constant. So this is going to be simply the area under that triangle. What is the area of this triangle? So let's find out this point. What is this point? See, so the area of the triangle is? Over 2a squared, because multiplied by the density function, right? The joint density function is, and so this is before z between 0 and a. And here you have to find out the area here. It's easier to find out the area here and subtract it. So that's going to be 1 minus that area. Let's find out this area. What is this point? Anyone? See, x is 1. So what is the height? X is 1. Huh? Z minus x, but x is 1. Z minus 1. I'm sorry, x is a, right? So
Y is Z minus A.
this point is z minus a, right? So this is, this whole thing is a, 2a minus z. So this portion is same. So what's the area? Minus z by 2a squared, right? Yes? So let's do the density function, derivative of this. Derivative of this is what? Derivative is with respect to z. Z over? And here? Derivative of this with respect to z. A squared, and you'll get the triangle there. Yeah, I'm going to fix it. Alright, so this is at home, and let's say I'm going to leave this to you. All right, so the joint density function is kxy squared. As you can see, x goes from 0 to 1, y goes from 0 to 1. So your job is to find out the density function. So you have to again go home and do this, except you cannot do it mentally because you have to integrate over this region. Just please practice at home. Few problems. Let me move on to the next one.